Object storage. I assume that everyone has a very high-level idea of what object storage is. What's the big difference between object storage and regular storage? Take an NFS server, for instance, and on the other side, a Swift object cluster. What's the big difference? The big difference is that object storage is exposed. Built for external access. The idea is that the customer or the software that the customer is running directly has access to the storage infrastructure, whereas in a classic environment, it goes through all kinds of levels. You can see here, you would have, in both cases, you would probably have a gateway, which is relatively easily compromised, or more easily compromised than the rest of the stack. Then in a classic infrastructure, you have load balancers, you have the web servers or application servers, and you have the storage all the way underneath that. So getting to the storage in this case is relatively difficult. In the object storage world, you have the application, and the application directly tells the object storage cluster, well, I want this object, or I want to put this object into the object storage cluster. And this is where the risk really comes in. Let's go over a couple other points. It's comparatively inexpensive. The idea is, or what OpenStack recommends for Swift is to build a white box cluster. It's not high-end storage hardware like an NetApp or an EMC that is maybe overpriced, but it's certainly well tested, and it is built to exacting specifications. The cluster in this case is built by yourself or built by the person who is going to operate it, or somebody who is paid by them. And cheaply made, it may be, it may not be, but the important point to realize is that if you don't do the architectural work right, then this may bite you in this respect. Highly available, of course. It's this is connected to the web 24/7, and any attacker that comes by and happens to have a way or find a way into your environment can bring you down. Redundant. Well, in this case, in most cases, you will actually have a load balancer in front, and so you will not have multiple points that you can attack at the same time. Scalable, that doesn't really have much of a security impact other than maybe having, or again, giving the attacker more points of contact. For instance, what do you do if you run out of bandwidth on your Swift proxies? You add more Swift proxies. You have like 3 Swift proxies in an HA configuration originally, and you will think, okay, these machines are highly loaded. What do? I add 2 more, 3 more behind the load balancer. As long as I put the same ring on all of them, they can address the same cluster. So you may have more points of exposure. And then the question is, when you build everything, the question that you ask yourself is what I built really secure? What happens? Am I going to come to work tomorrow morning and somebody is going to have can opener getting into my software? Okay, we have, in this case, in this talk, I limit myself to Swift, not Ceph and a couple of other object storage infrastructures, because every one of them is differently built, and I cannot cover all the topics in the same thing. So Swift cluster consists of a set of proxy servers and a set of storage servers. And those are connected by a network, by an internal network. And on the other side of the proxy server, there's an external network that requests come in through, and answers, pieces, objects go out. And from standard perspective, externally visible always means more vulnerable. Complex, the proxy server consists of many moving parts, especially if you do things like running HA proxy on your proxy servers instead of putting a hardware load balancer in front of them. The more individual software pieces you have, the more potential bugs and the more angles of attack you find. So the proxy servers would appear to be the more vulnerable piece of the infrastructure, but this is the real kicker. storage servers have services running. They have an account service, they have a container service, and an object service running. And these services do not authenticate, meaning authentication happens here. If somebody wants to get to a service, they need to authenticate against whatever authentication mechanism you have on the proxy, have the proxy servers configured for, and then gets to the storage service. Technically speaking, the idea with the authentication, no authentication, is really not that big of a problem if, and that's the big if, you separate your storage network from all the other networks that you are running. Because if you really have somebody who has access to the storage servers directly, they can extract objects from the services with handcrafted URLs. So, proxy server, again, the other big issue about the proxy servers is that they know about every object, they know about every location on the server, they know about the tenants, about the containers. So you have a whole bunch of meta information in there that can help you break open the infrastructure. And again, we have a number of different components. Memcached in the past, I don't know, probably some of you have already run into one Memcache debug or another critical issues that have been patched. And nobody knows, of course, how much, how safe this nowadays is. You have the account, container, and object servers. And you have maintenance tools. Specifically, also the replicators are a component that's important because they have access or need access to the data too. So, what do we do to secure the whole thing? First of all, here are a number of security topics, and I specifically don't limit my talk to, okay, put this in a configuration file, put that in a configuration file. The idea is to step 3-4 steps back and look at the big picture. First of all, address the big items, then come around and think about what can I do, how can I secure Memcached better, how can I secure that better. But the big things need to come first. Authentication mechanisms, of course, OpenStack authentication, standard authentication is Keystone. Swift also uses Keystone. You can, I currently have a customer who wants a Swift cluster by itself, so you can also have a alternative authentication. So you do not have to have a Keystone server when you do an OpenStack cluster that is not connected to a larger a Swift cluster is not connected to a larger OpenStack cluster. So we have, the Keystone and also Swift makes a distinction between tenants or projects. It used to be called tenants. It's partly called projects, partly called tenants now. And you have users and you have roles, which define that the projects or the tenants own a number of containers each. The users own things inside those containers. So you have, for instance, you have a tenant that has 3 users, that has some of the items are owned by one user, some of the items are owned by one user. But the users do not own containers. This is something to keep in mind. And yes, this is the important thing when you, from the user perspective, when you design your infrastructure, make sure that your basic configuration for the tenants and the users is correct, because if it's not, and if the user gets in that way, it doesn't even have to get around your security measures. This is just straight access. So that's the very big, very first thing that you need to keep in mind, that if you give a user access to something, even accidentally, then the user has access and doesn't have to get around security. And users have a tendency to do things with things that they are not supposed to be doing because they are users, and because it's interesting, and because it may be, it may seem lucrative, so make sure that your users are not, your own people are not the ones who are going to get you in trouble. So, and this is what I got to before, storage network between proxies and storage nodes. You have the storage nodes have services running on them, and these services are not authentication protected, meaning as long as you access the service on its service port, you will be getting an answer back regardless or without authenticating yourself to the server. The idea behind that was, well, we'll separate the storage network out. Unfortunately, a lot of customers think that's not necessary. And this is where you get in big trouble. There's always, of course, VLAN separation, but the best thing to do is this. Here you see, of course, the internet, thunderstorm, you have your bad people who are, I should probably have put some nefarious character or so in there. In any case, the router is, of course, the first level of defense. And then you have a public network. This is also, of course, that public network is also, of course, attackable from your OpenStack cloud, which is basically, which also uses your public network behind your public router. So if you have somebody in there who you don't trust, you can't trust, you don't want to trust, then you need to make sure that they can't see this, because your firewall and everything is not going to help you if your attack comes from here. So in a standalone cluster, of course, that problem doesn't exist, but you still have the chance that somebody finds a way through your firewall. But if you run the whole thing in a cloud context, which in Swift, in 90% of the cases, according to my experience, is the case, then protect your storage network, because you are exposing yourself to your own cloud. So, services security, these are just essentially common sense things. Do not run services as root. You tell it 1,000 times and the customer still does it. So make sure that when you architect something, when you build something for somebody, that they know to run the services as a service user. In our case, we are just, for instance, using Swift, but you can use anything as long as it is not root. And also to protect everything, make sure that the permissions for everyone who is not part of the user and the group are not allowed to do anything with them. Otherwise, you're again exposing yourself. The other thing, of course, is that's an ongoing topic with OpenStack Swift. In the beginning, HTTPS was simply not supported. Then HTTPS didn't work right. Then HTTPS had big performance problems. And a lot of companies said, well, let's risk it. You don't. If you really want to, or if you configure your cluster without HTTPS, you can do that. But put a load balancer in front of it that's a terminator, an endpoint for your SSL connection. Because if you run your authentication or open over the internet, which I have actually seen in reality, you are going to be in for a pretty bad time. So these are the ports that are open or need to be open on storage server. They need to be visible from a storage server to the proxy, to all proxy servers. So if you want, it's actually possible to firewall off the storage network entirely, even from your proxy servers, to mitigate the risk that somebody might hack the proxy servers and get to your services directly. So you have only a very limited set of ports that you need to have open in your firewall to get full operation of a Swift cluster. Again, no authentication. If you protect the whole thing with a firewall, you have at least one advantage, that people cannot get to the potentially configured but not protected services. But again, this is no protection. The network still needs to be separate from everything else that you have. So here, this is I pretty much preempted that. You have a storage hierarchy, you have accounts that By the way, does anybody know how the account database or databases look like? The account databases in Swift are actually a set of really, really small MySQLite databases. They are just taken as an object. So this is one of the reasons why deleting, for instance, deleting a large amount of containers takes forever, because they have to go through each and every of these SQLite databases to mark the container as deleted. So it is not the ideal configuration. It's not the ideal construct. This is something that is still around and that you still run as a risk. But it is, at the moment, it's just the only thing that I can say about it is it is what it is. Not everything about OpenStack is perfect yet. Nobody will, who's in their right mind, will claim that it's perfect. We've had, I mean, I went to the summit in Atlanta, and there was a pretty big bang about Neutron and a whole bunch of Neutron core people who were not very happy with what is happening right now. The same goes for Swift. There are a bunch of things that I would have done differently, that probably any of us would have done differently. But for some reason, they were designed in that way, and that at the moment we need to live with them. But we still can make a security impact by simply building in a secure manner. You can also, this is that's a slightly complex topic. You can use, depending on which authentication mechanism you run, you can use the metadata that is available for each object, for each container, to provide access lists for specific users, specific tenants on specific objects. So you have another level of granularity there. So other things on the proxy servers, of course, use SSL or TLS. Do not run it. Do not let your proxy server talk open on the internet. Use a non-privileged port for the proxy web service. This is a configuration issue. Some people run it on port 80, and some people run the web server that's behind it as root. Of course, we get back to do not run anything as root. So put the thing as at somewhere. And I get asked by the customers, well, isn't that complicated? If I have to remember port 5653 for something, isn't that complicated? Actually, it's not, because in almost all cases, the objects in the object store are controlled by some software. So the idea of the object store is to allow, for instance, a web application to access objects directly instead of having to go through a web server and whatever storage you have behind that web server. So the software knows which port to access, and this is actually sort of a security feature, although not really. It's with security by obscurity, which is because you're talking to some port, so people cannot simply guess, okay, it's going to be port 80.
So is there no well-known port for this?
A well-known port. I would have to look that up. I haven't really thought about that, but this is actually a good question. Technically, there should be, but as far as I know, there is not. This is in many cases the operator or the implementer decides what port it's running on.
Yeah, I mean, it's probably better to use a non-standard port anyway, right?
If you believe in security by obscurity, certainly makes sense. And I'm not slamming that. This is you certainly have a point. If everyone knew it was at port 5000, attacks could be handcrafted for that. If everyone runs it on their own ports, then it is less likely that somebody that somebody will guess it. So you get at least one class of attacks out of the way. But again, security by obscurity only goes so far, and this is something that you need to keep in mind. And then finally, load balancer. You can use a software load balancer. Swift by itself. OpenStack recommends HA proxy. It has its advantages. It's cheap. It is reasonably fast. It's also reasonably secure. But I think that in many cases, especially if you have a large cluster, a hardware load balancer probably will not only give you a performance edge, but also give you a certain security edge. And you don't have all the pesky problems with configuring the HA proxy correctly to terminate SSL connections. So, proxy server security, ensure authentication mechanism is properly secured. Of course, it's another point. You have Keystone. And if you don't configure that properly for the security that you need, then you, of course, also expose components. You expose the Swift cluster, but also you expose other components that are in your OpenStack cluster. So, yes, and then there's this, the one pesky topic of the hash collisions. You know, when in an OpenStack ring, you only have so many bits of hash. Only a certain amount of bits of the hash is going to be used. The reason being that the performance gets exponentially slower, especially things like erasing containers or creating containers. When you are using, instead of 13 bits, 14 bits, you use 20 bits, 24 bits. The downside to that, of course, there is a chance that there's a hash collision, and what can happen in this case, and why it's a security risk, is because if somebody had a way to handcraft the URL for an object that he wants to put, then the hash could be crafted in a specific way and could overwrite an object that is otherwise that would otherwise be what you put. Somebody else could put a malicious object in there that looks as if you have put it in there. Because the hash defines where the object goes, and if an object is in that place already, then it gets overwritten. That is a security risk, and there is a way to enhance or to reduce the risk of hash collisions. There is a configuration item Swift hash path suffix, so the hash path is artificially made more complex. The downside to that is, if you open up that value, you are giving somebody vital information about your object placement. And if the value is ever to be lost, then unfortunately your data is also going to be lost. So protecting that is going to be protected with your life, just like you protect your rings with your life. And finally, encryption from security from a user perspective. If I put something into a Swift cluster that somebody else has built, and where I don't know what the configuration for the users, for the tenants, and for all the other configuration items is, put the data into there, encrypt it yourself, decrypt it yourself. That way you can at least make sure that the people who are running that cluster are not going to be able to get into your important internal data. And the more critical the data is, I mean, you know, a couple of web objects, nobody cares. But imagine you have customer data in there. You do not want those exposed. Encrypt them before you even send them off to the Swift cluster. The downside, of course, is you have to propagate the encryption mechanism. You have to tell everyone or every bit of software that is accessing this, how the data is encrypted, how to decrypt it, propagate the encryption keys, and so on. And then finally, again, ensure that the user and tenant architecture is robust. From a user perspective, of course, if you run your own or you build your own users inside your Swift infrastructure, you'll have to make sure that those users and the access lists that they use are configured properly, and the users are not creating havoc among each other. And you know, with a company of 3, that's probably not much of a risk. If you have 1,000 employees, you can almost be certain that a bad apple is somewhere among them. So I'll open up the floor for questions. Yes?
Do you know what the reason was for
deciding not to propagate the Keystone token all the way back to the Swift storage cluster and have it terminated at the proxy instead?
As far as I know, the reason behind that was that the architecture for the storage server, storage servers were supposed to be agnostic of all the processes because they cannot directly see the Keystone server. It would have to be propagated through the proxy server anyway. Otherwise, you would have had to change the architecture entirely and really make the services, so those three services that I mentioned, account, container, and object, much more robust. This is, it's just a matter of performance. It's a matter. They were initially Swift had big performance problems. I remember Swift back to before Grizzly, before Folsom even. And back then, Swift performance was a big issue, and they basically probably thought, well, it's going to be faster that way. And if you separate it out, then everything's going to be fine. What they forgot to say is to make sure, what they forgot to think of is that users, if they can get away, well, we'll just run everything through one NIC. Let's hope it works. Unfortunately, this is something that probably the biggest security topic is not somebody who, nefariously built something, or so. But a lot of people simply sit down and say, "Oh, I'll take the risk." That's really where it's at. Any more questions? I have two things that I would like to recommend. One is the OpenStack Security Guide. It's a very long and very elaborate document that almost nobody knows exists. I've seen a lot of people asking me about OpenStack security, and I'm not the big security expert. I'm more the storage than the security expert. But this is something that you should know about. The other thing is the OpenStack Swift Administration Guide. Of course, it has a surprising number of good advice on how to configure your Swift cluster properly, and that way you already probably avoid a whole bunch of the traps that you can fall into. And if somebody wants to try that, this is something that I just wanted to see whether that really works on the wall. I put a V card in there, so this is.
Gotta get pretty close.
It's not working right. It's a little bit unsharp.
It's thinking about it. Here it goes.
Okay.